Okay, let's unpack this. When you think about the biggest challenge in education globally right now, it's this huge learning crisis. Just millions of students, especially in places, without tons of resources, they're just not getting the kind of support they need. And for ages, educators have this dream, right? Like, how do we give every single student that kind of personal one-on-one tutoring, the kind of thing that research like Bloom's famous Two Sigma problem showed could just massively boost learning. But I mean, how on earth do you do that for everyone? It's always been way too expensive, too complex to scale up. But now, suddenly we're in this era of generative AI. These large language models, things like GPT-4, they can talk, they can explain stuff, they can even act like a tutor. So the big question is, could this technology maybe finally be the key? Could it help crack that problem of personalized learning for everyone? And that's really the core question behind the research we're diving into today. Our source is this really fascinating new paper. It's a policy research working paper from the World Bank. It's called From Chalkboards to Chatbots: Evaluating the Impact of Generative AI on Learning Outcomes in Nigeria. So our mission here in this deep dive is basically cut through all the technical details, pull out the most crucial findings, the surprising bits, the key takeaways, so you can quickly get a handle on what this research actually found about using AI for learning, specifically in a place like Nigeria, a lower resource setting.
Yeah, and to really get the findings, it's super important to understand how they set it up. This wasn't just like a casual tryout. It was designed as a randomized controlled trial, an RCT, which, that's really the gold standard for figuring out if something caused a change. Did the AI program actually make a difference in learning?
Right, the cause and effect thing.
Exactly. So this happened in Benin City, Nigeria. They worked with first-year senior secondary students, so think early high school, across 9 different public schools. And the actual intervention, it was a structured 6-week after-school program.
Okay, 6 weeks. And what were they using?
They used Microsoft Copilot, which is powered by GPT-4. Students came in twice a week for these 90-minute sessions, and they worked in pairs, sharing one computer in the school's existing computer lab, talking directly with the AI tutor.
So pairs on one computer. What about the teachers? Were they just out of the picture?
No, not at all. That's a crucial point.
Right.
The teachers were very much involved, but as guides, as supervisors, they were trained specifically on how to use the AI effectively with the students. Their job was to help out if kids got stuck, with the tech or understanding the AI, and to make sure they were actually learning, not just like asking the AI for the answers directly.
Okay, so in a proper experiment, real schools, real kids, AI tutors, but with teachers guiding it.
Yeah.
So the million-dollar question, did it work? What happened to their learning?
Well, yeah, that's the key, isn't it? And according to the study, the answer seems to be a pretty clear yes. They saw some really significant learning gains. If you look at the final assessment they did, which covered English, digital skills, and a bit about AI itself, basically the stuff they worked on, the students in the AI program improved by 0.31 standard deviations compared to the kids who weren't in the program.
0.31. Okay.
Yeah.
And what about English specifically? Wasn't that the main focus?
It's a primary focus, yeah. And there, too, the effect was strong. Highly significant, 0.23 standard deviations improvement in English.
Okay. 0.23 standard deviations. What does that actually mean, though, in real terms?
Right, let's translate that, because this is where it gets kind of mind-blowing. The paper calculates that those gains just from the 6-week program, that 0.23 in English, that's like getting 1.5 to 2 years of normal, business-as-usual schooling in Nigeria.
Wait, say that again? 1.5 to 2 years worth of learning? In just 6 weeks?
It's what the data suggests, yeah.
Yeah.
Gaining almost 2 years of typical progress in that short after-school program. I mean, that's the headline that really makes you sit up and pay attention.
Oh, wow. Okay.
And just to give more context, the researchers looked at hundreds of other education studies, other RCTs done in similar kinds of places, and they found these effect sizes, this 0.23, 0.31, they're big. They put these results easily in the top 20%, maybe even higher, compared to other interventions. So these aren't just tiny little bumps. They're pretty substantial improvements.
That's incredible. Years packed into weeks. And, okay, something else really caught my eye here. They didn't just test the stuff the kids practiced with the AI, right? Mm-hmm. They also looked at how these students did on their regular school English exam at the end of the term, the one covering the whole year's work.
Yeah, that's a really important check.
And even on that standard school test, the AI group still showed a significant positive effect. It was 0.206 standard deviations higher.
Exactly, which is fascinating because it suggests the learning wasn't just stuck to the specific AI exercises.
Right. So it makes you wonder, did the AI help them build skills or maybe, I don't know, a deeper understanding that actually transferred over to their normal schoolwork.
That's the implication, yeah. Maybe it helped reinforce foundational English skills, or maybe they developed better ways to study, or maybe, like you hinted, just built confidence that helped them across the board in English.
Okay, so let's break down those gains on the program's final test a bit more. That overall 0.31, where were the biggest jumps? Which skills improved most?
Sure, so looking at the specific bits on that final test, the biggest gain was actually in AI knowledge itself. That jumped by 0.309 standard deviations.
Okay, makes sense they were using it.
Right. English skills, as we said, up significantly by 0.238. And their basic digital skills also got a decent boost, 0.139 standard deviations, also statistically significant.
Huh. So, even though English was the main target, just using the computers and the AI in this structured way seemed to teach them about AI and improve their digital literacy too. Kind of positive side effects.
Yeah, positive spillovers, exactly. Just from engaging with the technology as part of the learning.
Okay, all right, let's switch gears a bit. Did this help everyone the same amount? Or did it work better for some students than others? What did they find there?
Good question. Encouragingly, the study found positive effects for pretty much everyone, like students at different starting levels, different socioeconomic backgrounds. They all benefited significantly compared to the control group.
So there wasn't just helping, say, the kids who were already doing well.
No, the effect was statistically significant across the board. But, and this is an important nuance,
Oh, okay.
the size of the benefit, the magnitude, was stronger for students who started out with higher grades and those from higher socioeconomic status families.
Okay, so while everyone benefited, some benefited more, that raises questions about equity, doesn't it?
It does. And what's really interesting is how that contrasts with what they found for girls versus boys. While those higher baseline, higher SES kids saw bigger gains overall, the effects were actually stronger for female students compared to male students. And the paper suggests this might have helped close a gap because girls started with slightly lower baseline English scores in this group.
Oh, interesting. So stronger effects for girls. Why might that be?
Well, the researchers offer a few possibilities. For the lower SES or lower performing students, maybe there was just a bigger hurdle initially with the technology itself, like a learning curve just using the computer and the AI effectively before they could really dive into the English content.
Right, getting comfortable first.
Yeah, and for the girls, perhaps the patient, non-judgmental nature of the AI tutor, the personalized feedback, maybe that was particularly helpful for building confidence or addressing specific gaps they had.
That makes sense.
But it really underlines that if you roll something like this out, you've got to think about bridging those digital divides and making sure it doesn't accidentally widen existing inequalities.
Definitely. Okay, so what about how much they used it? Did attending more sessions lead to better results? Was there like a dosage effect?
Yes, absolutely. A very clear, strong link. The study estimated that for every extra 90-minute session a student attended, their score on that final assessment went up by about another 0.031 standard deviations.
So a pretty linear relationship then. More time, more gain.
Seems like it, within the 6 weeks anyway. And this is really interesting when you think about scaling up. Based on that consistent gain per session, the paper projects that if students did this for a whole academic year, well, depending on how often they attended, the gains could be huge, between 1.2 and 2.2 standard deviations over a year.
Wow, 1.2 to 2.2 standard deviations. That's potentially transformative, isn't it?
Exactly. That's the word they use, transformative potential. They also mentioned some qualitative feedback, observations, suggesting that maybe the first session or two had less impact while kids were just figuring it out.
Getting the hang of it.
Right. But after that initial phase, the positive effect seemed pretty consistent. It didn't look like it was leveling off within those 6 weeks, which suggests maybe the gains could keep coming.
Okay, so the learning gains look really impressive, potentially massive if scaled up. More use equals more benefit, but effectiveness is one thing. What about the practical side, especially places like Nigeria? Is this affordable? What's the cost?
Yeah, the crucial question. So the paper breaks down the cost. For this 6-week pilot, the direct cost worked out to about $48 per student.
$48 for this 6 weeks. Okay.
And they projected that running it for a full academic year would cost around $124 per student.
Okay, $124 for a year. How does that stack up? Is that considered?
Well, this is where the study gets incredibly compelling from a policy angle. The paper argues very strongly that this program is highly cost-effective, especially when you compare it to other ways of trying to boost learning.
How do they measure that?
They use a few different metrics. One is called equivalent years of schooling, or EYOS, gained per $100 spent. Basically, how many years of average quality learning progress did you buy for your money? And for this program, based on those 6-week results, it generated an impressive 3.2 EYOS per $100 invested.
3 years of learning value for every $100.
Okay. Then they looked at the benefit cost ratio, the BCR. And the numbers here are, well, they're kind of staggering. They estimate the BCR is somewhere between 161 and 260.
Whoa, 161 to 260. What does that even mean?
It means for every single dollar they invested in this program, they estimate it generated between $161 and $260 worth of educational value based on future earnings potential and things like that.
That seems incredibly high.
It is incredibly high, much higher than typical returns reported for many other education programs like traditional tutoring, especially in developing countries. They also used another measure, Learning Adjusted Years of Schooling, LAYS, which tries to account for learning quality. And they estimate participants gained up to nearly a full year, 0.9 years, of high-quality schooling benefit over their remaining time in school.
So really good value for money, it sounds like. Why was it relatively cheap?
A few key reasons highlighted in the paper. 1, they used existing school computer labs, no need to build new ones. 2, they used local staff who were trained rather than expensive external experts. And maybe most importantly, they used a free, readily available AI tool, Microsoft Copilot with GPT-4. They didn't need to develop or buy expensive, custom-made educational software or create massive databases of questions like older adaptive learning systems often require.
That makes a big difference in scalability, I guess.
Huge difference.
Okay, so we know it was effective, cost-effective. You maybe touch briefly on why it seemed to work so well. What was it about the way they used the AI?
Right, because it wasn't just, plopping kids in front of a chatbot and hoping for the best. The design seems key. The paper stresses that the AI was carefully set up to act as a tutor. They use specific prompts designed to make students explain their thinking, break down problems, engage in what learning scientists call desirable difficulties.
Desirable difficulty.
Yeah, basically challenges that make you think harder, process more deeply. It's not just about getting the answer easily, it's about the struggle, which helps learning stick better than just being told the answer.
Ah, okay. Less passive learning.
Exactly. And the teachers were crucial here, too. They monitored the students, made sure they weren't just using the AI as a crutch, getting answers without understanding. They guided the interaction. Plus, the content was directly linked to the Nigerian national curriculum, so it felt relevant to the students' actual schoolwork.
And it's pretty remarkable they got these results even with, real-world problems like spotty internet and power cuts, which are common issues there.
Yeah, that definitely suggests the approach has some resilience. It can work even when conditions aren't perfect.
Okay, so let's pull this all together then. What does this study really mean for the future? What are the big takeaways here? What's next?
Well, the main policy takeaway, the big one, is the sheer potential generative AI seems to have for tackling major education challenges. Things like teacher shortages, or just making teachers more productive, especially where populations are growing fast. Used the right way, these LLMs could be powerful partners for teachers, offering that personalized support at a scale that was just impossible before.
But the key is use the right way, right?
Absolutely. The study really hammers this home. It's not just about having the tech. It's about how you use it. You need that structure, the teacher guidance, the prompts that encourage actual thinking. Otherwise, as other research sometimes shows, students might just use it to, take shortcuts or offload their thinking, which could even be harmful to learning.
So thoughtful implementation is crucial.
Crucial. And the scalability looks good because it's relatively low cost per student and uses free tools, avoiding those massive software development costs. But, and it's a biggie, but the equity issue is vital.
Right. The fact that some groups benefited more.
Exactly. It's a warning sign. If we just roll out AI without tackling the underlying gaps in digital access and basic digital literacy in teacher training, we could actually make inequality worse. So any large-scale implementation needs serious investment in that surrounding infrastructure and training, not just the AI itself, to make sure everyone can benefit fairly.
Makes sense. What about future research? Where do we go from here?
The paper suggests quite a few things. We definitely need longer studies to see if these effects last. We need to see how it works in different places, like rural areas maybe. It would be great to see direct, rigorous comparisons between this kind of AI tutoring and traditional human tutoring. And also understanding better how the skills learned with AI, maybe AI literacy itself, transfer to other subjects or tasks.
Lots more to learn still. So, okay, the bottom line from this deep dive into the World Bank paper seems really hopeful, actually. It's compelling evidence that generative AI, if it's designed and used carefully as a tutor alongside teachers, can lead to really significant learning gains. And cost-effectively, too, even in tough environments like Nigeria. It feels like a genuinely promising tool against that global learning crisis.
It does. And maybe the final provocative thought the paper leaves you with is this. AI is developing incredibly fast. We have this potentially immense power at our fingertips. There's a huge opportunity here to harness it for education, but we have to be really intentional about it. We need to invest wisely, not just in the shiny tech, but in everything around it, to make sure these powerful tools actually lift all students up and don't just end up widening the gaps we already have.
A really important point to keep in mind as AI becomes more embedded in everything. Well, thanks for joining us for this deep dive. We hope it gave you some valuable insights into this important piece of research and what it might mean for the future of education.